Hey guys, how you doing? It's Coach Scott with another fun video about chemical reactions. Let's go into the single replacement reactions. We'll talk about those. Okay, so single replacement reactions are pretty simple. All right, they have one element will substitute for another in a compound. All right, so we have A plus BC is going to yield AC. They flip-flop, if you would, plus the other element B. So this reaction will proceed when an elemental anion is more chemically active than the compound's anion, or when an elemental cation, the negative one, is more chemically active than the compound's cation. So those are skeleton reaction. A plus BC yields AC plus B. So these two elements are competing, okay? In this case, it's going to be A and B. The element C is what we call a spectator ion, since it's really not part of the competition. Okay, it's in the compound regardless of the outcome. It's on the compound on the reactant side and on the product side. So if A is a cation, it's going to displace the cation in BC. If A is an anion, it's going to displace the anion in BC. So usually a metal ion will compete to displace a metal ion in the compound, or a halogen ion, fluorine, chlorine, bromine, iodine, will compete to displace a halogen ion in the compound. Now, I'm not going to make you memorize the chemical activity of the elements. I will give you the chart, or I'll give you the information, and I'll expect you really to infer it from the provided reaction. So these reactions can only proceed in one direction, since one of the more chemically active elements is in the compound. It's not going to be displaced by the element it displaced. So in the first reaction, we see that zinc is more chemically active than hydrogen. So zinc displaces the hydrogen and forms zinc chloride and hydrogen gas. Now, in the second reaction, we see that chlorine is more chemically reactive than iodine. So chlorine replaces the iodine and it forms magnesium chloride and iodine. All right. So these reactions do not proceed. We tell you that. Bromine and chlorine. So what do you think is really going on there? Iron and magnesium does not happen with magnesium sulfate. Well, maybe, okay, in this case, bromine would need to displace chlorine. It can't. They're both anions. We can infer from this fact that the reaction does not proceed, that bromine is less chemically active than chlorine. In the second case, we've got to compare these two cations, iron and magnesium. So we can infer, because the reaction did not proceed, that magnesium, all right, is more reactive than iron, or that iron is less reactive than magnesium. So it did not proceed. So yeah. So we can use this to set our chart up. We can use this in reasoning and these reactions to determine how chemically active these elements are. So anyway, that's all for now. This is Coach Scott signing off, saying we'll talk about more of this in class, and we'll be able to predict some things from these reactions. Okay, this is Coach Scott saying toodles.